Thank you so much for inviting me here, and I'm going to give a talk about some small topics. I have actually a very big problem that keeping to any topics that I can do in 45 minutes is very hard. Because as I'm going to argue, the future is potentially extremely large and valuable. There is so much to say about it. And that in turn might mean that we have a quite important duty to fulfill in making the future better. And also an interesting challenge, because changing and shaping the future is quite tricky. So, as was mentioned, I'm working at the Future of Humanity Institute. So I'm trained as a computational neuroscientist. That is, I'm a computer scientist who believes I can say something about the brain. Then, because of my interest in human enhancement, I ended up at the Future Humanity Institute when we did a project on human enhancement. Thanks, by the way. And I've been there ever since. So I've been living in Oxford for 14 years. Our institute has a remit of thinking very big, very, very long term, literally about the fate of humanity and how to make it better. If we're not thinking thousands of years ahead, we're doing something wrong. So a lot of the questions are, what makes life good? What would be a good outcome for humanity? Deep philosophical questions. That then lead to other practical issues like existential risk. Why are existential risks very important problems? What can we do about it? So that in turn might lead to even more specific questions like which risks are most worth working on? Not necessarily the largest one, but which ones we might want to fix. And that in turn might lead to very practical research. So at our institute right now, we have a lot of people working on technical AI safety, working literally on coding artificial intelligence so it's safe. But we also have a team working on AI governance. How do you, even if we figure out how to make safe artificial intelligence, how do you convince Google and the governments around the world to use it? What questions exist in governance that we should know from a technical standpoint? Other parts of the Institute are thinking about biotechnological risks and the other existential risks. I'm right now working on what you could say is the upside, not just the threats to humanity, but also how good could the future be. So I'm writing a big book about basically if we survive and get our act together, how much value is there in the future? And a lot of this also ties into questions about applied rationality, how to think well about highly uncertain things. As I will hopefully have a time to talk about, our ability to predict the future is very limited. And our ability to think well about uncertain things is also limited. So how do we make the best decisions given our human limitations? So to start with, here is a wonderful example of what the English would say, comparing apples to oranges. These are several different curves, but the main thing that they have in common is that on the horizontal axis is time, and the light blue one corresponds to life expectancy worldwide. The slightly darker one, that is wealth per capita. The green one corresponds to the fraction of people who are not living in extreme poverty. The yellow one is how much energy humanity is acquiring per person. The purple one corresponds to essentially how dangerous our weapons are. How many people can be killed per hour given certain assumption. The purple one corresponds to the fraction of humanity that lives in a democracy. I think the most obvious thing from this graph is that for a long period of time, very little happened. 1,000 years before Christ, up to the Roman Empire, not much change. Indeed, 1,000 years after Christ, you still didn't have that much change. And then everything changed very, very quickly. And that was partially because of the Industrial Revolution. Luke Mulhauser argued, he made this diagram, that this is actually a sign that maybe the Industrial Revolution was the biggest thing ever for humanity. That might be the second biggest thing in my opinion, because when we got our brains and expanded out of Africa, we already took charge of this planet for good and ill. Meanwhile, our cousins, the chimpanzees, well, they're still living in their forests, while we found ways of living on the savanna, in the forest, in the desert, in the ocean, in the Arctic. We have spread to every ecological niche on the planet, and we are dominating it for good and ill. that is because of our brains are a slight bit smarter than a chimpanzee. Not necessarily that much smarter, but our ability to communicate and coordinate makes an enormous difference. Our ability to remember things culturally, when somebody invents something, we can teach it to our kids, and they will teach it to their kids, which means that we accumulate power. And our ability to then externalize this in a technological way, that allows us to get more food, to spread to new places. That has really transformed the world. So in many ways, we have been extremely successful, except that we're also quite aware these days that we are also messed up with the climate. We're having trouble with biodiversity, and we have invented weapons of mass destruction, which might end the state here on Earth. So we have an interesting set of problems. And these paradoxes, that is what I'm interested in exploring. Now, one question is, what can we say about the future? We can, of course, say, well, why not extrapolate these curves? The problem is, when you extrapolate curves, things can go badly. So this is a joke diagram from The Economist, which is about the number of razors on disposable razors. They kind of have been plotting it and make various predictions about at what point will we reach 14 blades per disposable razor, which is obviously absurd, yet that is what happens if you extrapolate. In fact, using this hyperbolic curve, it predicts an infinite number of razor blades somewhere by 2030. A more positive example is this. So this is how much wealth per capita Americans have, and this is the energy use per capita, and this is a plot since over time. So this starts after the Second World War, and for almost, let's see here, the 30 years, you have this perfect line. Any economist would say it's obvious that in order to be richer, you need more energy. And indeed, the data strongly supports it. Then the oil crisis happened, and suddenly the curve turns horizontal with a bit of shakes. Basically, the Americans kept on getting richer, but they didn't use that much more energy per capita. Something had fundamentally changed. In this case, it was an oil shock that got them to be a bit more interested in saving energy. Suddenly, the new price mechanism was in, but if you were to extrapolate the old curve, you would get totally the wrong result about the future. So in many cases, something has to give. One has to understand the system and what is happening. In some cases, we can predict the far future really well. This is a map of where solar eclipses will happen in the year 2981 to 3000. And I'm willing to bet that if you were actually to stand in one of these paths, you would indeed see a solar eclipse at that date. It's very unlikely that this is going to be wrong, because the way planets move is extremely predictable. It's Newtonian mechanics with a slight adjustment for Einstein. It happens in space, in vacuum, no friction. And the most likely way this prediction could be wrong is there are two possibilities. One is some kind of error in the microprocessor in NASA's computer. The other is that humans in the future will have moved the moon or Earth. I think those are kind of the most likely reason why this would be wrong. So in some domains, we have enormously good predictive powers. In other domains, not so much. One of the biggest problems is, of course, whenever humans get involved, we can change the rules quite profoundly. So here is a prediction from 1667, where after the Great Plague in London, where Sir William Petty did an estimation of how many people would be killed by the next plague in London. And his prediction is totally wrong, because there was no next Great Plague in London. Well, knock on wood. Basically, what happens was people took the plague seriously and built better sanitation. Plagues of this kind became a problem of the past. We changed the future, which made the prediction in some sense wrong, but it was still useful because it got people to actually act in the right way. So in many ways, we want to be like Sir William Petty, make bold predictions that convince people to prevent them from coming true. All right, so what kinds of futures can we do? If we, instead of trying to calculate numbers, try to be a bit more careful about what qualitative patterns do we see. So here is a very loose diagram we might make. Right now, on the vertical axis, we have some kind of measure of human value, the size of a civilization, how many people there are, or how happy they are, or whatever it is that really counts. And of course, philosophers in the room will have a long list of interesting alternatives for that. And so far, a lot of this has been going up fairly exponentially. But it seems like there are kind of 4 possible futures here. One is that it levels off, and the future is going to be roughly like this. 1 million years from now, people are still getting parking tickets. That's very unlikely. It's a very odd future that still has parking tickets 1 million years in future. Another one is of course that tomorrow morning Donald Trump bangs the wrong button on his desk and we all go extinct. That's unfortunately a bit less unlikely, I think, than this permanent mid-level. Some people would say, yeah, maybe we have a crash of civilization, return to some simple hunter-gatherer society, relatively materially poor, and it keeps on going. I think this one is also unlikely for the same reason as the permanent mid-level seems weird, because it's unstable. We invented agriculture and the Industrial Revolution once. It's likely that we can do it again, especially for interesting ruins hanging around. Then, of course, there is the real optimistic scenario. Those exponentials keep on going. They go far up. How far? We have no good way of telling. We will become something very, very different. Our civilization would be as incomprehensible to us in the present as our civilization would be to our hunter-gatherer ancestors. The interesting thing about these trajectories is that to some degree we have a choice. I'm going to argue that we have ways of trying to nudge things. And I'm going to, in this talk, focus a little bit on what are the extinction risks, which might of course lead to some low level too, and what are the really grand futures. Because I think that quite often we have a reputation at FHI as doom and gloom people. We're always talking about how things could end up badly. All the bad ways you could use artificial intelligence, or the way a nuclear war could ruin your day. But the reason we do that is not because we really delight in making people depressed. It's because we're really optimistic. We can't wait until we get up there, whatever there is. But that requires us to take steps today to avoid disasters. And you want to be optimistic in your outlook, both because if you think the future is nothing good, then you're not going to be very interested in actually saving the world, because the best you would gain is a meh future. And of course, you're also going to feel like, yeah, I'm pessimistic, so I don't think this is going to work. So why should I even try to fix the world? Why not go and have a beer instead? But if you're optimistic, you will say there is a lot of value at stake. And you might say, and maybe, just maybe, we can actually do something to increase the chance of getting there. So what are the existential risks we need to worry about? So we had a bunch of ancestors and other cousins, other species that went extinct. Some of them probably because of us. So we know species like ours can certainly go extinct. And there have been a few close calls for us humans too. So this is Lake Toba in Indonesia. And about 80,000 years ago, this happens to be a volcano, and it had a huge eruption covering a fair bit of Asia in a lot of dust and leading to global climate changes that last at least a decade. There is also some genetic evidence. It's controversial, so this is by no means settled science, that suggests that at that point the total human population went down to a much smaller size. There might even have been just a few hundred families alive. We were this close, if this is true, to extinction. We were lucky that a few hundred people survived, and then once the dust cleared and the weather got good again, repopulated and settled the world. But we could have gone extinct there. Similarly, in 1983, the 26th of September, this hero did nothing. That's really why we should be revering Stanislav Petrov. Stanislav Petrov was running in the bunker beneath Moscow, the Soviet satellite system, watching for American launches. The satellite starts blaring that it looks like the Americans have launched a preemptive strike. He doesn't quite trust the system. His job is basically to check that everything in the hardware seems to work well and then make a phone call. And given the tensions at the time, which were really the coldest part of the Cold War, it's pretty likely that the authorities in the Soviet Union, who were really expecting the crazy President Ronald Reagan to launch a preemptive strike, would probably have retaliated, and that would have been the end of our civilization. Petrov didn't do anything. He waited and waited and waited, and it indeed turned out to be that it was a false alarm. So he saved us all. It wasn't very good for his career, though. That's the sad part. But this is a real hero. We named a conference room at our institute after him. So generally, existential risks are the ones that the severity is as extreme as it can get. And they're not affecting just the current generation, but they're affecting all possible future generations. So there are many other bad things that can happen. A species can go extinct. We might have a dark age. A dark age would be bad for several generations. But even during the dark age, people were falling in love and singing songs. There are good things you can do even during a dark age. There might be a global tyranny, but if it doesn't last forever, well, yeah, that's just a tragedy. The problem with existential risk is that there is no way of ever undoing them. So they're kind of threatening to permanently curtail our potential. And this has important effects on value. So obviously, the people who would be killed by an existential risk would be harmed. But also all future generations would not occur. And that could be, as I will show, a lot of future lives. Many, many more than are currently alive. And of course, all the cultural value and artifacts we have would be lost, as well as the artifacts and culture produced by the future. Some people might also argue that species have a value in themselves. This is interesting that people don't really like using this about humanity, but we use it quite often in environmental ethics to talk about why it's wrong to kill off even a single beetle species. So at least according to some views on environmental ethics, it would be at least as bad to wipe out humanity as killing a beetle species. And then, of course, it might be that we are the only conscious beings in the universe. One can argue about this, but you could argue that maybe without the human perspective of the universe, there is actually no value at all. It's just an unconscious universe where the planets are moving around without any meaning. So in that case, the loss of humanity might be even more important. I also think we can make a good fairness argument. Just as I shouldn't discriminate against you who are far away in the audience because you're far away from me physically, you're worth just as much as the people on the front row to me. We should, of course, not discriminate against the people who are far away in time. Especially if you believe in relativity theory, it's totally obvious that it must be invariant. Because otherwise, if you get into a spacecraft and move at a high velocity, you should change your ethical judgments about the different people, which seems just totally wrong. Yeah. And of course, going extinct means that we can't do anything else. There are some really depressing philosophers who really think that actually going extinct is a good idea. Now, some of them may even have good arguments, but what's the probability that they're correct arguments? I think we want to at least consider things very carefully before going extinct. Once you're extinct, you can't notice that there was a logical problem in some footnote on page 17. Yeah, I'm just going to briefly rush past various kinds of existential risks because I think most of them you know, and we can always discuss them later on because we have more fun stuff to deal with. So there are these big astronomical risks, and the good news is they're very, very rare. Supernovas, they might affect Earth every 100 millionth year or so, and have so far probably not caused that much extinctions. We get some solar flares that might actually harm our technological infrastructure, and they might actually be common enough that we need to care about it. It might not be the end of the world, but without the internet, well, it would just be almost as bad, at least to us who are internet addicted. And then, of course, asteroids hit us all the time, but big enough to actually threaten our survival, they're relatively rare. So it actually turns out that when you sum up the astronomical risks, they're probably not worth worrying too much about. It's a good thing we have Spacewatch, because before Spacewatch was launched, we didn't actually know what the actual risk from asteroids was. Now we know well enough to know that we just need to keep a loose eye open for a surprise asteroid. Similarly, geophysical risks. There's a fair number of everyday disasters we need to be resilient against, like the hurricanes and earthquakes that harm us every year. The really big ones to be worried about is, of course, ice ages. We're living in an ice age right now, except that it's on a temporary break. So I don't know whether there was an ice cover down here in central Spain. In my native Sweden, it was at least a mile thick. My dad kind of entertained me as a kid, explaining to me that, you know, about the ice age, where our home stands now, there was a kilometer of ice. And some scientists think that the interglacial is going to end soon. This was actually a dominant theory in the 1970s. The models were suggesting that maybe the ice age was returning. But my dad, who was also well-read in science, pointed out there are some other scientists pointing out something about carbon dioxide and carbon emissions heating up the planet. And of course, if ice melts, we're going to have water already up to our doorstep. He was about as pessimistic as I'm optimistic. Another geophysical risk we need to actually have some concern about, but again not enormous, is supervolcanism. Basically you get these enormous volcanic eruptions which could disrupt agriculture on a continent-wide scale. They happen roughly once every a few 100,000 years, so the probability is not big enough to be too worried about. Still, you might want to have an idea about what do we do if one day the sky goes dark and we can't do agriculture. My friend David Denkenberger has been working on various technical solutions to actually get food in those kind of situations. The nice thing is this works also against asteroid winters and nuclear winters and other things. The basic trick is pointing out is that actually wood, this is all carbohydrates. It's just that we can't digest them. But in such a disastrous situation, we would be very motivated to take our furniture and turn it into something edible. So he's been looking at ways of industrially converting this into something we could eat, either chemically or by using fungi or insects. Might not be the most palatable food, but if you don't have anything else, well, there goes the furniture. Generally, when it comes to really big disasters in the past for humanity, I think it's the biological ones that are really have been putting a mark on us. So you have these big epidemics that have killed off significant fractions of the human population. These ones don't matter. Because the Black Death was very bad news, but that can't actually wipe out humanity. After all, a parasite needs a host to survive. It's pretty unlikely that a natural pandemic could do it. But we actually know that cytrid fungus has actually killed off several amphibian species. So it's possible for some parasites to actually kill off entire species. In this case, it's because other frogs and toads act as hosts for this fungus. So they're swimming in the same ponds as the vulnerable frogs, and that has been very bad news for them. Another interesting example is, of course, the flu, and here is a plot of British flu deaths as a function of time, and you get a peak every winter. And then there is a particular one peak that is kind of literally off the chart. And this is, of course, what I assume is called the Spanish flu everywhere but here. Now, actually, you should be proud that it's called the Spanish flu, because the reason it became known as the Spanish flu was that the health minister of Spain actually announced to the world that we have a really dangerous epidemic going here. We don't really know what's going on here because nobody else seems to be having it. The reason was, of course, that Britain, France, and Germany all had the epidemic and they're keeping quiet about it. Which is exactly the wrong thing to do if you have a big pandemic, because you need to work together to stop it. So actually, you should be proud that it's sometimes called the Spanish flu. Then we have, of course, the human-caused risk. And the interesting part here is that they tend to dominate, I think, over the natural risk. So we have a classical problem that we wreck ecosystems, which is bad for our civilization. We also have, unfortunately, the most well-documented statistical law in all social science, the Richardson the size distribution law of wars, which shows that large wars are rare, but they follow a very regular statistical pattern. So one can kind of calculate how likely it is to get a super war that kills everybody. And unfortunately, you get a non-zero number. It's not that small. It's kind of 1 in 1,000 per year or something like that. One should, of course, be very skeptical about extrapolating a curve like that. And then, of course, we got the currently very popular climate change problem, where, again, normal climate change just makes the world worse. It's the really extreme climate change that could actually harm us very seriously. Even that is relatively unlikely, But of course, a climate change world would also put a lot of stress on our other systems. And that, I think, is where you actually get real existential risk from this, because we're dependent on a very complicated infrastructure of technology, of food, of energy. And a world that has a lot of stresses on that can break down in other ways. You get systemic risks that emerge from that. And then, of course, I don't have time to get through it, but of course, obviously, nuclear war is kind of a real risk. And then, of course, if you have a bit of imagination and like new technology, you can immediately come up with even more future technological risks. So we do a fair bit of work on the problems of artificial intelligence, which right now are zero. But in time, AI is going to become more and more powerful, at which point it might actually become very risky, especially if it becomes smarter than us. Because remember, we're slightly smarter than chimpanzees. We took over a planet. If we have software that's slightly smarter than us, it might accidentally take over a planet and then optimize it for shareholder value, making paperclips, which could be very bad for us. There are also interesting issues, for example, about really weird physics risk. How do you even bound risks that we don't know how to think well about? So the good news here is that the natural risks and global catastrophic risks actually are pretty small. The risk per year is probably on the order of maybe 1 in 100,000, 1 in a million of some really, really big natural disaster. And we can do things against natural pandemics. We just need to be better at it. It seems that our own created risks dominate, which is both bad news because we made the world riskier for ourselves. It's also good news because that means we can also have an effect on them. And it's hard to predict the future risks, and especially when they're complex. But many of them are actually possible to mitigate in interesting ways. We can actually take steps to deal with that. So that was the risk part. This is kind of the reason why we might be concerned about the curve going straight down. What about the straight up one? Well, in fact, quite a lot of curves are going really well. The number of absolutely poor people in the world have actually declined a lot. People are complaining, I notice right now, that the number of users of internet have not risen quite as fast as we hope. It's about the increase last year was about half what we had hoped for. But given this trend anyway, we're reaching relatively soon saturation. Within a few decades, everybody on the planet will be connected. Our maximum lifespan has actually been increasing at a remarkably straight line since the 1800s. And predictions of where it will level off have always turned out wrong. And this is not because of any magical life extension pill. This is because of simple antibiotics, better healthcare, vaccines, and things like refrigerators. Now, of course, some of my friends in the life extension world are also trying to directly affect the aging process itself. It's not at all implausible that we might make this curve go up even more. And of course, if you care about nothing else in this talk, you should know that just by sitting here, your life is getting a bit longer. There is medical research and the improvement in living standard happening right now that actually measurably will increase your life a few minutes per day. Similarly, and I don't have the time to get into this because this is of course a huge fun topic, we can improve our way of thinking. Some of it is super simple, like getting exercise, sleeping enough, and not drinking water with lead in it. Really good tip. Other forms of education, which is of course expensive and takes a lot of time and really annoys a lot of students, but it gives you about 2.7 IQ points per year up until a point. And there are various mental methods that can actually strongly improve our thinking. But we also are getting more and more methods to actually directly improve our cognition, whether that is in the form of smart drugs, ways of stimulating the brain, genetic engineering, or just smarter interfaces, or just having these smartphones where we outsource part of our brain to the cloud for good and ill. And of course, we also outsource a lot of our cognition to groups of people. We're getting better and better at that. So in the future, I think we have a pretty good reason to believe that we are going to be effectively smarter, if not wiser, than we are in present. Similarly, it looks, at least from a physics standpoint, that actually we're not going to run out of resources. We might still have a lot of hard work getting there, especially since we want to get there as fast as possible. But it looks like when it comes to energy, actually you can get more than enough if you actually just can deploy a lot of solar panels. You also want to, of course, have energy storage and energy transmission that's really good. You would basically live on about the same surface area as, I guess, this stage up here in terms of solar panel. That would actually power a modern Western lifestyle if we could set it up properly. Also, manufacturing, again, it's not like we're losing any atoms. It looks physically possible to use that energy to give us a ridiculous amount of stuff. Most stuff is totally indefinitely recyclable. And the key to this is, of course, automation. This is where the software and AI comes in. Because when we manage to outsource something to machines, typically that means that it's not done at the human scale of productivity, but many orders of magnitude more. So the end result would be that if we can actually do enough renewable energy, probably because we develop good nanotechnology, and have the software to automate recycling and production, we will indeed be living in a fully automated gay space communism luxury. Of course, the AI, as I mentioned, we might have an interesting problem here of getting the superintelligence to behave itself. It's a profound and interesting problem we want to solve before we get to superintelligence. But normally when people talk about post-scarcity societies, we're kind of thinking about rolling in material wealth. But it's also actually post-scarcity of services. If we can actually automate a lot, many of the services which are currently expensive are also going to happen. So when we think about healthcare, for example, one reason not everybody can get healthcare is that right now we have scarce doctors and they're expensive because we need to pay their salaries. If we can automate part of healthcare, that might be bad news for the doctors, but good news for the world. When it comes to total human population, it also is an interesting question, how many we can be. And I realize I'm totally running out of time, so I'm going to speed up things a lot. But basically, people have been given various estimates, and it all depends on how we want to relate to the environment. You can say that maybe we want to have 100 million hunter-gatherers living a simple life, or some sustainable agriculture. Or we might say, no, we want as many people as possible because people is what make life fun. Let's turn all the surface area into the agriculture and the oceans into algal farms and live in giant arcologies, and then we can have 7 trillion people on the planet. Which might not be very good from an environmental standpoint, but I think it can be totally sustainable. And just think about the amount of art and beauty and music and other things we are going to produce. And we can probably do this for a very long time. And we can, of course, get outside the planet. So Jeff Bezos apparently this week mentioned that he believes that about 1 trillion people can live in the solar system. I think that's a low estimate. He's being conservative. There is way more resources. And that's, of course, just in the asteroid belt. It turns out that you can actually pick apart planets. I have a paper demonstrating that we can actually pick apart Mercury to build a shell around the sun. And then we get 10 to the 26 watts of power, which is way, way more than Earth receives. It actually turns out that physics that allows beings like us to change orbits of planets, disassemble planets, collect the full energy of a star, direct it in all sorts of radical ways. Now, this is kind of far out compared to many normal pictures of the future. And that's, of course, just getting started, because if you have the energy of a star, you can, of course, send off your space probe to other systems. In fact, we could already, in the 70s, we already sent a space probe that could have gotten to another star system if we had just aimed it slightly differently. Of course, the Voyager probe will not do anything if it reaches another star, because it's still an inert lump of matter. It doesn't last that long. But even with 70s technology, we can slowly send things to other stars. Turns out that it's rather tricky to make rockets that go there. So big spacecraft are probably not going to be that effective because of the horrible, evil rocket equation. We can talk about that later on, why it's horrible and evil. It turns out that actually launching using lasers, like the Breakthrough Starshot project, looks way more effective. In fact, this is what in that paper Stuart Armstrong and me demonstrated, that you could use this to span the universe. We could send probes using one Dyson Sphere to all the stars in all the galaxies that can be reached. That's a lot of places. We probably have about 30 billion Earth-like planets in the galaxy, maybe. We got at least 300 billion solar systems that each could house at least 1 trillion people. And actually, if we go out in the universe, if this is roughly the visible universe, and depending on how fast you move your space probes, you can go out a certain number of billions of parsecs. So basically we can reach about 8 billion galaxies if we go really, really far. Each of them with 300 billion stars and so on. And of course the future is even longer. We're just talking about stuff that has happened right now while the stars are still burning. They're going to keep on burning for 1 trillion years. At least the little red dwarf stars, they're very energy efficient. Kind of hot-headed stars like ours will run out of energy in just a few billion years. That means, again, an enormous number of possible future lives. Typically when astrophysicists then talk about the later eras, they get more and more gloomy and so because it sounds like there's nothing going on there. And yes, it might be hard to subsist in a world that only consists of black holes. But it seems like the degenerate era, after the stars burn out, actually has enough matter and energy to do a lot of interesting things. It might be that actually that's where most of the history of the universe is going to happen. So we might think about what do we actually want to do with the universe. And one thing is, of course, maybe we just want to go out there and seed life and happiness and beings on all the planets. We just spread it out. Maybe we convert matter to the Dyson spheres running happy uploaded minds. Or maybe we plant gardens. If you really want to do computation, you want to wait until the universe is late and cold. So you kind of expand out and then you sleep until the stars go out and then you wake up and harvest. On the other hand, if you want to keep your civilization together, the expansion of the universe will actually separate the galaxy clusters. So you actually will not care about stuff that's too far away. So you will go out and take a few galaxy clusters, maybe move them together, and then have your happy civilization running for trillions of years. And then, of course, some people will say, no, we're going to try to survive as long as possible. And it looks like it's possible at least for 10 to the 33 years. Others, of course, say, no, wait a minute, this is just crazy, Anders. I don't want to move galaxies. I don't want space. I want to have tea with the vicar while watching the cricket on the local village green. I want to have good social relations with my friend. Now, let's not mess up the world. So this is an interesting case because it's not about maximizing stuff, it's about not breaking certain rules. So one of the big projects I'm doing in my book is trying to see how much can we get the different views here to work together so we can all agree on roughly that we want to go in the same direction. So what can we do? Well, it looks like the future is super big and super bright. Potentially there could be up to 3 or 4 Google future lives. And even if we just subsist as hunter-gatherers for 800,000 years, that's still 800 billion people in the future. So we should really make sure we don't go extinct. We might also want to coordinate a bit before spreading out, if there is stuff we need to coordinate, whether that is moving galaxies or a general ban on let's not make in self-replicating superintelligence war machines and things like that. That's bad form. We might actually work hard to boost our solidarity across time and space. And of course, I think my main point of doing this is that I want to give people a sense of hope. There is actually a pretty bright future here out that we could aim at. And I think it's important for a civilization and a person to feel like my personal and my civilizational and my species future actually can be rather good. That gives us energy to actually work for tomorrow. I'm kind of totally mega running out of time here. I'm just going to run past some slides to show you that I've been thinking a little bit about our ability to shape the future. So basically, as I said, predicting the future is really hard, and most of the time we don't even care about predictions being right. If you look at most predictions you find in the literature and at corporate presentations, they're probably from the entertainment budget. We feel wise when the futurist is talking about something grand, but then we keep on doing what we normally did. And that's kind of a problem, because ideally we want decision-relevant information. In particular, in my work, we have been looking at, can we predict when we get human-level AI? And the answer seems to be, no, not really. So we know that experts on a domain are not experts on the future of a domain. So these are, for example, a lovely paper where some chemists, they got an issue of a journal and were asked, okay, in 5 years' time, which papers here matter? Which are scientific findings that matter? Which ones are going to be cited? Which ones are going to be forgotten? And the answer is the chemists were lousy at doing that. This is their own domain. This is papers just like what we read every day. Then, of course, it turns out that when we talk about artificial intelligence, if you look at predictions about when we will get AI, they don't change over time. failed predictions have the same distribution at all the predictions. Experts and non-experts give roughly the same numbers. And generally, there are good reasons to believe that this is true, because nobody is getting any feedback about their predictions. We're not very trained at doing this. And when you actually do a survey of when AI, you can't maybe see all the little gray probability curves correspond to individuals, but they're all over the place. And when you ask people about, well, when will AI be able to act as a retail salesperson or write a New York Times bestseller, you have a fairly big spread. But you also have this interesting thing that here is doing all human tasks. And this is being an AI researcher. Many of them actually believe that we're first going to get AI that can do everything a human can do, but it's going to take a century before it can be an AI researcher, which is obviously wrong. The lesson here is just that the people even in the field don't know what we're talking about, because we tend to lump things together here. You want to actually look at the details that work. I don't have the time to mention Philip Tetlock, except that you should read him, and he's done some amazing job on actually making people better at forecasting. Typically by stringing together people who are good at making forecasts about the near future, taking the ones that prove themselves, putting them into groups, having these teams get access to training and other information that help them become less biased. And that way you can make decent forecasting relatively short term. And generally, of course, when shaping the future, we know prediction doesn't work very well. So we shouldn't try to do that. We should look at our decisions. So instead of trying to predict super rare events, we should be ready when they happen. When you notice that suddenly we're at a crossroads of history, you should be kind of ready to try to run down the right path. But that's rare, and you need to be honest with yourself, because most of the time we love to give a talk starting out something like, oh yes, now we're living in a unique era of history. I have no doubt Romans were doing this in the Roman Empire. Setting your priorities really well is also very important. If you get them slightly better than average, then you have won a lot. Some organizations have managed to push history, and typically it doesn't work. But sometimes, if you're persistent enough, it can work. It worked for the Abolitionist Society. They managed to get rid of slavery. The Fabian Society essentially came up with ideas of standard European social democracy, worked for it, and actually got most of what they wanted. The Mount Pelerin Society, they wanted classical liberalism and worked for it for a few decades and got neoliberalism up and running. Silent Spring by Rachel Carson is, of course, setting an idea into the intellectual milieu that eventually takes over. Now, no political party is anti-green, except maybe some Americans. And of course, if you just make the future obvious enough, like the DARPA Grand Challenge for autonomous cars, suddenly everybody believes that the future will be autonomous cars, and then it will indeed be autonomous cars. And of course, there are other ways of shaping the future. So those of you who are entrepreneurs, you have a real amazing chance. You probably have a better chance than most of us in the philosophy department because you make things. So generally, sometimes we can delay bad things or speed up good things. And of course, we might want to avoid going extinct. But creating institutions, that matters. And quite a lot of things happen when you create a network or a cluster. So this is a roadmap of the Roman Empire. It turns out that to this day, it's left economic traces in the economic growth rate of different parts of Europe. You can actually measure the impact of Roman roads. Just because they existed, they have created a pattern of infrastructure that kept up going for 2,000 years. You can collect information that the future really needs, and you can set standards. You can create that platform everybody wants to use. So, there are ways of shaping the future. I've been arguing that there are existential risks that we really want to avoid. I have also been arguing that there is glorious, amazing, really weird futures that we could achieve. And in the here and now, we actually have some chances of actually becoming slightly better at shaping the future and turning it more utopian. So,
So we're going to move on to questions. If somebody prefers to ask in Spanish and have us translate the question, that's fine. Pasamos a preguntas. Si alguien prefiere hacerla en español porque no se siente cómodo pero quiere algo, lo traducimos sin problema, ¿vale?
So if we take the argument that derail puts forward, which is the main difference between us and chimpanzees is our ability to coordinate by believing in a higher intangible concept such as religion, nations, and we take on the other hand the fact that these are the ones causing ourselves the biggest risk. What kind of institution, concept, idea would we have to have as a species to help us avoid putting ourselves in danger?
So I think what we need is some form of intertemporal responsibility. We have a fairly well-developed system of thinking about justice and responsibility towards people who exist here and now. We don't have a good system for thinking about future generation and our responsibility to them. It used to be that that was tied together with many of religious ideas or other constructs, but it was a relatively weak link. And when many of the religious ideas also fell to the wayside, we kind of lost that. So right now we have a lot of abstract things that probably needs to be turned into something that has more emotional impact. So I think this is something that is actually where I do think philosophers and artists and writers could do a great deal of work on, creating a better sense of our intertemporal responsibilities. I sometimes talk about the temporal golden rule, but it began when I was thinking about surveillance information. I realized that you should treat information from the past like you want the future to treat your information. But of course, that's also kind of true for people. You should treat people of the past in so far you can as you want the future to treat you. And maybe conversely. I think we need to build up moral intuitions about this, which is going to take a fair bit of thinking and work.
Well, thank you for the talk. Since we're all living in a pale blue dot, why aren't we all working in the same direction and avoiding your last competition, as you say on your slide? It seems to me there's no competition between all of us. I mean, we should all be addressing the same issues.
Partially it is because we're bad at coordinating. So we evolved to live in small tribal communities where everybody knew everybody else, and people who were strangers were generally dangerous. So we had a fairly limited ability to coordinate. It was good enough to enable us to scale things up. And once we got states, we found other institutions and tools to help us coordinate. But they're still rather limited. We haven't incorporated them into our own thinking very well. Spread of our circles of compassion. And we certainly have invented better ways of coordinating, whether that is the internet, Wikipedia, or Kickstarter. I think we need to work much more on that. Just because we intellectually also know that we're on a pale blue dot doesn't mean that we all agree on the fundamentals. You can have very different fundamental values. So when I'm working on my things in the Grand Futures book, quite often I get a lot of people saying, yeah, but it's totally obvious that we should do this. And others in the room immediately say, what? That's just evil. So we need to find ways of resolving that. One interesting idea that Will MacAskill has suggested it, but in the long run, before we're spreading out, we probably need a long reflection. We actually need to try to coordinate ourselves a fair bit before really starting to spread out. But that sounds very utopian by today's standard. But I think what we can do is we can make the tools to make the tools to make the tools that make it possible. So we can start working on ways of improving tolerance. We know a fair bit of things in social science about tolerance. We know, for example, that exposure to people belonging to other groups in a friendly setting tends to reduce prejudices very strongly. We also know that beta blockers also do it, so maybe we should put them in the drinking water. Might be a bad idea, but generally there are things we can do here. We can come up with tools for that. But generally, we should be astonished that we can do it as well as we can. We can live in cities with millions of inhabitants. That's really weird. If you take a normal animal that has a flock size of a certain number and then you create a flock that is orders of magnitude larger, typically things go really badly wrong. We humans have somehow managed to handle that.
So how did you use the Dyson Sphere to move a star?
Yes, I'm glad you asked. Yeah, I'm having so much fun in my book because I have a worked example of how to move the entire Milky Way if we want to avoid colliding with Andromeda Galaxy. So the basic trick is this. You have your star, it emits sunlight in all directions. You put a hemisphere of aluminium foil around it. You can actually have a Dyson Sphere where the parts are kind of tilting when they're on one side. So now you reflect all the sunlight in one direction. This is an exceedingly wimpy rocket. The acceleration is really, really tiny. But if you keep doing this for about 4 million years, you will statistically get relatively close to another star, because the stars in the galaxy are, of course, all moving at different velocities relative to each other. And of course, you can speed things up if that star also has a Dyson Sphere kind of pushing them. So now you can get two stars coming close. And now we do a gravity assist. Basically, the gravitational force bends the trajectory and actually can change the speed. This is what the Voyager probe used to get out of the solar system. So in this case, now you can give the stars a velocity of tens of kilometers per second in any direction you want. Now do this for other stars in the galaxy. You can use binary stars to park extra stars into orbit, or actually charge up the binary star so it has more energy and you slow down the star, or deliver that energy to speed up a star. You can use these ones to steer stars past the central black holes, so they're ejected from the galaxy, acting as a really crazy rocket engine. And that way you can actually make the Milky Way move out of the way of Andromeda Galaxy. I don't think it's worth it. I think this is actually a really stupid method, but we can work it out using current science. There is no doubt that this would work if somebody were to keep up putting aluminium foil in the right spots around stars and doing this for long enough. And I think this is the sheer beauty. We're a bit like ants, but a lot of ants moving in the same direction can totally change an ecosystem. We can actually change the entire ecosystem of a galaxy and actually move stars around. Yeah.
So nowadays we can sense, we're capable of sensing that in the developed world we are constantly increasing our standards of living, which is actually great. And the more developed we are, the more developed some countries are, the faster they develop at the same time. However, on the countries that are less developed, what happens is that they have a different speed from the standard in the developed world. So I think that this could develop into a higher inequality in the world. So what are your predictions for global inequality?
So it's an interesting fact that global inequality has decreased. This sounds very weird, because if you're a Westerner, you're kind of steeped in the current debate that inequality is increasing and really problematic. But the thing is, inequality might have increased inside various Western countries. But when you look at the total world and just compare people without caring about borders, it's very clear that we have this growth of a global middle class, largely because the Chinese have gotten richer. So what is happening seems to be, according to growth economists, there is this idea of a growth path. I don't know whether I believe it, but generally it seems to be easier to have a rapid economic growth if you're behind, except that you start from a lower level. Once you're a really advanced economy, actually your growth rate seems to be lower. This is, of course, why China and various other developing countries have been doing relatively well. They're still very vulnerable, however, so there are other problems here. The real problem are not the Chinas of the world. I think in the long run, India is going to do fine. It's just that we might want to speed things up. The problem are the ones that really get left behind because they have really bad governance that makes it very hard to invest, that is makes it irrational for people there who know useful skills to stay and so on. Those are the ones that actually risk being really left behind. In the long run, I think everybody is going to be joining up the global middle class. It's just that we might say that maybe waiting this many generations is not acceptable, morally speaking. So I think what we should try to figure out is actually kind of how to help failed nations. That seems to be one of the important and rather tough problems to deal with. In the case of other nations, I actually just think we should aid technology diffusion. That we should try to keep borders open. That seems to be having very, very effective effects.
Existential risks that artificial intelligence poses. Do you think it's worth pursuing, and why?
I do think artificial intelligence is worth pursuing, partially because it's very hard not to pursue it. It's in many ways a natural effect of a lot of other research we're doing in neuroscience, in computer science and decision theory. So it's going to be very hard to say, actually this is so scary that we need to stop that. Because then you need to stop a lot of very, very different disciplines, which seems to be a non-starter. And the benefits are enormous. After all, if you can actually automate many tasks, that means that humans don't need to do them. They can do something more interesting. There are many tasks that are too dirty and nasty that you don't want humans to do them at all. And of course, you could make the world much wealthier and indeed solve many of the hardest problems. So I do think that if we could get safe and beneficial superintelligence, then we should totally go for it. The problem is, how do we even know if we're getting to that? So I think we need to work much harder on figuring out AI safety before that. The good news is that while some people in the AI community think that, Bostrom and the others, very kind of just weird Luddites going on about as crazy superintelligence in the far future, we're trying to do serious things like autonomous cars. They actually have the same problem. An autonomous car needs to be able to read the behavior of other people on the road. That is not just an ethical problem, it's a quite tricky legal and intelligence problem. And I think convincing companies that wouldn't you like to make software that's law-abiding, that would be a very good idea. After all, you don't want software that ends up in court. But interpreting laws, that's about as hard as interpreting ethics. So I think actually we have good reasons to work rather hard on this, and that we can convince many of engineers that actually this should be part of good engineering. Just like if you're making any other equipment, you want to add safety engineering. So the really tricky thing is, can we be really certain about that we have a safe system when we press the button and it actually becomes way smarter than us? That remains to be seen. It might turn out that we might hope for a slow development in AI. I'm a Scandinavian, I'm very happy to say. I have my doubts about the current hype bubble about machine learning. Machine learning is doing amazing things and it's going to change the world, even if it doesn't produce real AI. But still, it's very likely that for a while people are going to be embarrassed talking about AI. And that might actually be a good thing, as long as we remember that the goal should be to automate things in a useful way to make us the better off.
Could you speak a bit more about the rules of rocket theory?
Oh, the rocket equation, yes. So the problem with rockets is that a rocket contains fuel, which it expels backwards, and then it moves forwards. Now, a normal rocket starts by expelling a bit of fuel, and that will, of course, speed up the entire rocket, including a lot of other fuel, which is then going to be expelled. So the problem is, the faster you want it to go, the more fuel you need. But that makes the rocket heavier, so it accelerates at a more sluggish rate. So the problem is, for a given velocity, the amount of fuel you need goes up exponentially. So this is, if you think about how current rockets look like, where you have this enormous construction and on top you have a little capsule with astronauts or a satellite. You need this enormous device to carry a rather small device into orbit. And if you want it to slow down at the goal, then you need another rocket on top of it and an even smaller payload. And this is the rocket equation for normal low velocity transport. If you want to go close to the speed of light, then you get to the relativistic rocket equation, which is even nastier. So this is why I totally hate rockets. Rockets are the wrong way of getting around. So if we really, really want to personally get to space, I think orbital elevators might be the best way. So this is based on the idea that you could use super strong cables, which might just barely be physically possible. And if you have a satellite in geosynchronous orbit, it always stays above the same spot. And then you essentially lower a cable down from it and extend it a bit outward with a counterweight, and now you have an elevator cable. And then you can just take the elevator to space. No rocket exhaust, it's very clean, it can be solar powered. It takes a while because there is a limit on acceleration, and there is a load of technical problems on how to make this safe and effective. For getting around in the solar system, I think actually using solar sails and big batteries of lasers to push them is probably the best way of doing it. But we'll see what happens with the Breakthrough Starshot project. It's aimed at making people enthusiastic about the future and inspiring them. And one of the nice side effects, it's actually putting in a lot of money in developing the basic technology for testing this. So we're going to learn so much from it.
Smartphones, everything that we are every day like this, walking in the street, and how this is going to affect the human relationships in the future. How human relations are going to be, because today I see that even myself, we are having dinner and everybody is with the smartphone. So I guess sometimes I am worried about our kids in the future.
Academic performance.
Mm.
Okay, so they are thinking all the time in the social media, and I don't know how this is going to impact to our kids in the future. Did you make some studies about this?
Nope. But I have opinions. So I'm also trying to wean my husband from using a cell phone when we are having dinner. So far, no success. It's very hard. But the reason, why are we obsessing about the cell phone? I think there are two reasons. One is a bad one is a good one. The bad one is that we just develop habits. It's a natural response when you're not doing anything in particular, when it's kind of a bit awkward, to bring up the phone and kind of tune out your surroundings. It's kind of, we do get this kind of, I wouldn't call it a full addiction, but certainly it's a bad habit. The other reason I think is a good one. We actually want to stay connected. The reason social media are so strongly affecting us is that we're social beings. Now, we might say that the relations we have over social media are weak ones, while the real relationships in the family ought to be stronger and always have priority. And I think there is some interesting issues on how we balance actually our relationships. So there are these studies showing that there had been a decline in very strong interpersonal relationships, at least in the US. And I think it's true in many European countries too. But it seems that that's also a relocation to a lot of weaker relationships. So these days I have an enormous circle of friends online. I might have fewer people who are really deep friends, and that might be bad for my psychological well-being. Still, from a kind of career standpoint, from an information standpoint, I think having a lot of contacts actually is a good thing. Up until the point when LinkedIn, of course, constantly barrages you with the message that, oh, wouldn't you like this guy as a contact? Because he's a friend of a friend of a friend somewhere. So the real problem we have here is that we have just invented social media. They didn't exist 20 years ago, really. And we're still coming to terms on how to use them. When the cell phone arrived, we had this big debate about, is it acceptable to talk in the cell phone in a restaurant or in other situations? And gradually we developed social norms. Similarly, we developed norms about reading. In many cases, when people are nosing around in the cell phones, they're actually reading something. If they had been doing that with a book, we wouldn't be as annoyed at them. But now it's this symbol. So part of that is kind of the response of any elders towards the young generation because they're doing things wrong. Partially it is because we haven't adapted very well to it. And there might indeed be addictive sides to this. There might be very interesting pathologies in social media. So the current debate about fake news, I think, is just the top of the iceberg. There is a deeper issue here about how we get our information in our civilization. It used to be that there existed a few central broadcasters and you couldn't get information from much else. Now we get it from a lot of different sources, and we also reflect information back, which typically means that a piece of information will bounce around between many people. And at every bounce there's going to be a bit of bias, because I retell the information I heard in my style, and that's going to bias it in some particular direction depending on who I am. The problem is, of course, this leads to emergent bias. Many people worried about fake news worry about kind of deliberate misinformation campaigns. I think they can be handled. The real problem is the misinformation we generate ourselves. But we have solved that in other domains. It just might mean that we need to solve it here too, and that's going to take a lot of effort. In science, we found ways of using peer review and testing and experiment and statistics to see if the findings actually hold up. It might be that we need to figure out better ways of handling our collective epistemology. And that's going to be a tough project, but I think it's worthwhile. So I'm not super worried about the young. It's just that I wish I could communicate with my niece and nephew, but they don't use the same apps as I do. I think I'm carrying around a phone. I occasionally send messages to slightly younger friends. I have no idea what a Snapchat is, which means that I can't communicate that effectively with my niece and nephew. Then again, my mother, she's always possible to reach by landline, and my grandmother, 108 years old, I better write a physical letter to. So we might end up with a society that actually has a lot of generational divides based on forms of communication. That might not always be a bad thing. Actually, that diversity might be useful, but it's really cumbersome. And in many cases, we make assumptions about how to communicate that make certain groups unable to participate. We need to think about ways out of that.
Many entrepreneurs in this room might be the founders of very important companies in the future. Do you have any suggestions of what would be the fields, products, services that might help to better have an impact in the future if one would have to either shape its business model today?
So I think shaping the future, generally we want to figure out how to do coordination and insight better. I think the technology part is doing rather well, actually. There might be technologies we want to get early. So I alluded to this idea of safe-making technologies. There are some technologies that we can predict are going to cause some form of trouble. So for example, quantum computers are likely to crack a lot of encryption we use today, which might be bad news for the overall safety and privacy. So we want to have quantum safe encryption, and both Google and NSA are working on that. So that's an obvious case. Similarly, we might see that, some people might want to try geoengineering to fix climate, especially if it's a climate crisis. That's risky and people are rather nervous about it, but it also looks like it's something somebody could do unilaterally. So maybe ways of undoing climate engineering would be super useful. Biotechnology promises a lot of cool stuff, but also some rather risky applications. Ways of mopping up genetically modified organisms or detecting pathogens really fast would be useful for a lot of things. So one of the nice things about Luddites is that you can always ask them about their biggest misgivings and then realize, hey, they're giving me nice business models here to think about. In many cases, I think we can make use of that. Generally, I do think setting up your kind of institutions, platforms, standards, or whatever, that really shapes the future the most. And we want to shape it in the direction so it's kind of open. We don't want to lock ourselves in, except we want to lock out some really bad possibilities. If we can drive a horrible disease to extinction, perfect. Let's get rid of smallpox, let's get rid of polio, mumps, and all of those. That's kind of the options we don't want. But we also want to keep our options for the future, because we might realize later on that we're totally wrong about many important moral things. These days, racism, sexism, and homophobia are recognized as being bad. It might be that in a few decades we're going to realize that, eating meat, whoa, that was actually really seriously immoral. Why didn't we make that step earlier? So we might not want to lock in our values too hard. We should be open for changes there. But I also think that actually there are areas where we need to fix that are kind of crucial. So energy production and distribution and storage seems to be super important, because if we have enough energy, then we can do the recycling and material extraction fairly well. I've been talking to a guy who's running a mining robotics company. And the name of the company is Offworld. You can kind of guess where they're aiming. But they actually got real robots in the mine, which is awesome. And the real dented robots drilling in actual rock. That's really useful as long as you have energy to power them. Similarly, we might want to work hard on figuring out ways of automating that kind of jobs. I think that really opens up a lot of possibilities. I also think that directly improving human life can have big effects. After all, we sleep about a third of the time. Why are there no great improvements in how to sleep? Our beds are nice, but couldn't they be way better? In fact, making sure that people who have sleeping problems can sleep really well would probably improve the number of quality-adjusted life years tremendously. Just like, of course, improving medicine and improving other forms of well-being would have big effects. So your question is kind of open-ended because there's so much we could improve. Then, of course, you need to run that through the prism of what you think you can do, what you think you can get paid for, which is also quite important. I like the effective altruism motto of thinking about scalability, tractability, and neglectedness. Especially the third one is what I really like. There are many important problems that people are not working on, sometimes for really stupid reasons. Sleep is low status. So people are not really investigating how you could improve sleep. And some of these problems turn out to be enormously scalable, as we found with computing. So I think there is plenty of interesting things here to think about.
Okay, we have two more, only two, sorry. But we'll have drinks afterwards, so you have a chance to approach Anders. I had seen you before and somebody on this side, but I don't know. Well, we'll start with you over there. Thanks.
Okay, thank you. I wanted to ask because we have mentioned before that getting better with coordinating, you live in huge cities, not the internet. However, it does seem to me like, for example, politically, society is increasingly more polarized. So maybe we're getting better at coordinating superficially, but not agreeing on a deep level on what our aims are.
Yeah. So coordination, it sounds so nice. It's a single word, but there are many parts to coordination. Just like you say, one is communicating and coordinating as a group. But you can make coordinating as a group easy without making groups want to talk to each other. And I think that is kind of what has happened thanks to the internet. Any group and any set of people can easily find themselves. But there are no really nice tools in this communication system that makes it then possible for the groups to have a good debate and dialogue. People have been experimenting with various ideas, but so far none of them have really panned out. And it might turn out that the solution is not at all technical. It might be some other form of social organization or institution. So I think one shouldn't be too concerned that coordination is all about software and fiber optics. I have a feeling that it's going to involve something way more humanistic.
Okay. Since the first row have easy access to Anders and you're finished, I'm going to give you a question over there.
So you mentioned the need to be more empathetic towards people in the future. So I guess one shortcut for achieving that for me would be, if I were to live forever, I would be very sympathetic to anything that happens in the past, right? So how likely do you think it is that our generation will achieve that, either through anti-aging or through cryonics? And how do you think it will impact how we think about the long-term future?
So generally, I think if you expect to have a long life, you are going to care much further into the future. If you don't expect to survive till middle age, it's kind of stupid to plan for the far future. You might still want to help building the local cathedral for future generations, but your own interest in the future is going to be relatively limited. If you expect to live to 100, it's not just that you're going to expect to be in the future, you might also be held responsible. So actually, I do think life extension has a lot of interest in knock-on effect. This is controversial. There are other people who say, no, it's really bad. You're taking the place of somebody who could exist in the future. I personally think the future is big enough for both of us. So I'm happily signed up to cryonics, actually. So I might end up there and some post-human saying, so Dr. Sandberg, you made certain predictions. We have your own PowerPoint. Let's see how it turned out. At which point I will, of course, happily say, yeah, okay, it beats being dead. So I do think life extension is both morally and practically actually a good idea. Yes.
Okay, well, thank you very much because you've been a great audience, and thank you, Anders.
Thank you.
Yeah, if you want to keep track of events like this one, if you go to altruismo.es, you can sign up to our newsletter where we announce all the events, and we'll have more cool stuff coming up. And now we have some drinks, so feel free to reach out to Anders or to any of us if you're curious about anything that we do. Thanks.
Thank you.
Thank you.
Yeah.